Someone once asked me, do you even remember the Hindenburg airship disaster? It was horrible. And you want to build airships again? Friends, welcome to the podcast about airships, in your own words, which is dedicated to the project New Generation Airships. I am Alexander Mynko, the host of this podcast. We begin. Yes, we want to build airships again and revive airship building in Russia in the 21st century. Thanks to Vadim Zubkevich, Deputy Head of Project Management at NOVA, Chief Designer of Airships, today we are going to talk about why airships are now safe and why passengers and cargo are better protected in an airship rather than in an airplane. We thank Vadim Vasilyevich for providing this information. The history of all disasters of large airships in the 20s and 30s is explained, in my opinion, by three reasons. The most important one is that they flew on fire-hazardous hydrogen, which requires very careful control of hydrogen leaks. The formation of explosive flammable mixture of hydrogen and air, it is dangerous both during the flight itself and it can be an exacerbating factor in the event of an airship accident. The second factor that led to disasters and flight accidents was the fact that rigid airship structures are very complex spatial structures that are very difficult to calculate using analytical methods. Modern numerical methods of calculation allow to calculate loads in each of the elements very precisely. Therefore, the strength and reliability of such a structure can be ensured much more easily and reliably with modern design methods. And thirdly, at that time there were no developed norms of airworthiness, and airships were designed without taking into account any experience. There were no developed norms of strength, norms of airworthiness, what can be done, what cannot be done, what elements must necessarily be in the structure and design. And the aggravating factor was, of course, that all those disasters of large, rigid giants of the past had a very depressing effect on the public consciousness. Besides, war was coming, and airships were mostly useless for war. After all, it is a peaceful transportation for passengers and cargoes. And the main funds at that time were invested in the development of warfare aviation. That's why airships were forgotten. Now, with modern design methods, modern materials, more durable and lightweight, the airship design will be much stronger and more reliable. And rigid certification methods, like any other aircraft, prescribe the norms for thrust capacity and redundancy of the main components, which makes the new generation airships much safer compared to the airships of the past. But the main component of safety today is that we are now flying not on dangerous hydrogen, but on safe helium. And even in case of any leaks, damage, hard landings, or, God forbid, even accidents, there can be no incidents related to gas ignition. However, an airship is still a flying machine, so it must be designed accordingly, and it must be operated properly. An airship is not a high-speed aircraft, it is a floating vehicle, so it is more exposed to atmospheric turbulence. Therefore, the operation of a properly designed airship, with all the regulations, with all the certification, the operation of such an airship is, of course, subject to environmental constraints. In some cases, these restrictions may be more severe than for airplanes or helicopters, but not in all cases. If the airship is operated properly, flying is perfectly safe. If, for example, flights are not allowed in conditions of heavy icing, not just icing, but very heavy icing, very heavy snowfall, which is also dangerous for airships because of snow buildup, increased mass of the structure, atmospheric turbulence, and strong thunderstorms. Such operation is certainly not acceptable. It must be avoided. Modern meteorology and data on the state of the atmosphere and air environment allow predicting such phenomena with a high degree of probability. And it is possible to organize airship operation taking into account these conditions, when you can fly, when you can't, where you can fly, and so on. The same restrictions apply to the operation of airplanes. Airplanes and even helicopters are not operated in all weather conditions either. Therefore, an airship is a means of transportation that has limitations under certain weather conditions. These limitations must necessarily be observed and not violated. What else speaks in favor of airship safety? It is the fact that an airship is a relatively slow-flying vehicle. Safety is very much influenced by the speed of flight, because the airplane flies very fast, and in case of any unfavorable situation, the pilot has to make a decision very quickly. The pilot of an airship does not need such fast reactions, therefore the airship itself is quite stable. That is, its center of mass is located below the center of application of aerostatic force. Therefore, from the point of view of flight, the airship is a very stable aircraft, which ensures its safety. How else can atmospheric turbulence affect the flight of an airship? It's getting caught in very strong upward and downward currents. That is, upward currents can pull the airship above an altitude where the gas occupies the entire volume of the envelope. Current airship design standards require that the airship's air-gas system be designed for vertical, converging, descending velocities on the order of 15 meters per second. That is, if the air-gas system is designed correctly, it is redundant. It functions normally even if some of the components fail. In such a case, a vertical velocity of 15 meters per second, up or down, does not result in an excessive increase in pressure inside the shell. Thus, the strength of the shell is fully ensured for the vehicle to fight powerful upward and downward currents. Adequate power capability is required. Airships of the past were underpowered. That is, their propulsion capacity per square meter of characteristic area was not high enough. Modern airships will be equipped with more powerful engines, will have more powerful power, so they can fight with such upward and downward flows and go into the mode of rapid altitude gain. Airships are required to have a standard of redundancy to provide for any situation, including the failure of any individual components. That is, the certification process always considers failures of all major components, checking to what extent these failures lead to complication of flight conditions or to a catastrophic situation. If the failure of some component leads to the development of a catastrophic situation, it necessarily requires the redundancy of this component. Modern airworthiness standards are also required in the design. All of this must be ensured, and all critical components must be redundant. There is also such a mandatory requirement. Airships fly with a slight overweight. Modern standards of strength and airworthiness of small airships allow them to fly with a slight overweight. Also, modern standards for the strength and airworthiness of small airships require that in the event of a failure of all propulsion systems, a sufficient ballast reserve be located on board. When the ballast is discharged, the airship can enter a free flight state so that the pilot can select a landing site and land safely. In this case, of course, the structure would be damaged. How damaged will it be? Well, it should be seen. Most likely it will only be damaged partially, and basically the airship can be restored. But it will be absolutely safe for cargo and passengers. So flying the new generation airships will be absolutely safe for cargo and passengers. Up to the point that if we have a complete loss of gas in a small soft airship with soft shell, where there are no rigid structures, just the shape of this shell is maintained by internal pressure. The airworthiness standards for such small airships require that there be an unbreakable device in the membrane, which separates the gas compartment in the shell of such an airship from the air compartment. Thus, if the air tightness of the shell is broken as a result of, say, a slight collision with a motorized aircraft, the gas begins to escape intensely. Then we open this membrane, and all the lifting gas is replaced by air. Even in this case, we maintain the shape of the shell. According to our calculations, even if all the gas in the shell is replaced by air, and all the propulsion systems fail, the rate of descent of such an airship will be around 8 meters per second, due to the fact that the shell is still a powerful braking factor. This is the speed at which skydivers descend with sports parachutes. And such landing will be absolutely safe for passengers and cargo. Summarizing all of the above, it can be noted that modern materials, modern requirements for airship design, modern use of safe, non-flammable helium make the airship no less safe and maybe even safer than traditional aircraft, airplanes and helicopters. Also, nowadays, such a level of development of modern flying equipment and level of design has been reached that nobody has heard about disasters of flying machines for a long time because of the fact that they initially have some pilot's mistakes or some deviations in operation. That is, a properly designed aircraft, if it is properly operated, is absolutely safe.